Let us consider the course of a precipitation hardening with artificial aging using the example of an aluminium copper alloy with 4% copper. At room temperature, the microstructure of this alloy consists of two phases. One matrix of alpha mixed crystals, as well as rough copper precipitates, which are found primarily at the grain boundaries. The material is heated in the first phase of the precipitation hardening. The copper precipitates become smaller in this process. The copper content of the alpha mixed crystals increases accordingly. The strength of the material increases slightly. The single-phase area of alpha mixed crystals is reached between about 510 degrees Celsius and 560 degrees Celsius. Now this temperature is maintained in this temperature range till all precipitates are dissolved. This process is called solution annealing. The copper atoms are now integrated, statistically distributed, in the aluminium crystal. The microstructure is a homogeneous mixed crystal. If the material is cooled slowly again, the copper excess would again precipitate in the form of rough copper-rich phases. But the cooling is very rapid in precipitation hardening, so the copper atoms do not have sufficient time to come together. They are forced to remain in the solution. The microstructure after quenching is therefore also a homogeneous mixed crystal, which is now oversaturated with copper. The oversaturated aluminium mixed crystal has a higher strength than pure aluminium, but can still be formed well. The material can be formed into a component in this state. The finished component is left to lie for some time. We speak of aging. In case of artificial aging, this takes place at an increased temperature. In case of natural aging, at room temperature. Submicroscopic fine precipitates form during aging with the grain. These precipitates work as finely distributed obstacles for the dislocation movement, and the strength increases considerably due to this. The precipitation hardening therefore mainly includes the following three steps: solution annealing, quenching, and aging.